Hello students, welcome to the first screencast of the new school year. Every Thursday that we have a class, something similar will be presented to you, in which I present to you a real-world problem, and I will solve it using the information and techniques that we are learning in class. Then, I will present to you a problem that is up to you to solve, using very similar techniques that you just heard me describe and calculate and solve in the screencast. And then you'll have to submit your response through Canvas, and you can do that in a few different ways that I will explain at the end of the screencast. Look at the map in front of you. What are you looking at here? Well, it's the world, of course, and to the left you can see a bunch of colors and then a bunch of numbers next to each color. This map I thought was interesting. This represents, and this was from the data in 2010, that represents life expectancy of a child in each country. In other words, what that means is, for a child born in any of these countries, they are expected to live as long as the key demonstrates. So for example, if you look at, the United States, it's kind of a darker kind of green, or lighter depending on how you're looking at. That matches up with the key 74.7 to 77.1, which means a child born in the United States is expected to live anywhere between 74.7 and 77.1 years. If you look to our neighbors above in Canada, the life expectancy there is a little bit higher. But if you look around the world, you can see the different life expectancies, which I thought was interesting to share with you guys. You can see it by continent in different countries. Anyways, what does that have to do with anything right now? Well, that's what our problem's about. It's about, don't think it has anything. Is we're going to try and calculate life expectancy according to this problem. All right, now here's the problem. It says, for the period 1900 through 2000, the life expectancy at birth, which is represented, as you can see right here, is lowercase e in years. For people born in the United States can be modeled by the function e is equal to 3.66 times the square root of t plus 40.6, where t is the number of years since 1900. That's interesting. We're going to talk more about that in just a bit, because what t is, it's not specifically a year, it's the number of years since 1900, and that is very specific meaning. It is our duty to answer the question, in what year was the life expectancy at birth about 75 years? And then we'll have to explain that. Alright, so let's do just that. First and foremost, if we reread the problem one more time, we notice that the equation that we need to make use of is the following, and it helps to rewrite the equation, which I'm going to do right now. E is equal to 3.66 times the square root of t plus 40.6. Alright, there we go. Now, one thing you always want to do is you want to really examine your variables and what they're saying to you. In this case, and let's move this piece of paper off to the side there, we have two variables. And our two variables are e and, of course, t. Now, if we look back at what the problem is asking, it says e in years. So we know the life expectancy at birth is represented by e, and our unit is in years, which I'll abbreviate. But then I wanted to talk more about t. T is the number of years since 1900. T is the number of years, so it still represents a number that is a number of years, but it's the number of years since 1900. Since 1900. So let's say we calculate, we do all our calculations, and we realize that t is 5. Does that represent year 5? No, not exactly. That represents 5 years since 1900. 5 years since 1900. So the math we'd do would be 1900 plus 5 years would be 1905. Let's say we calculate and we get t to be equal to 30. Well, okay, that's 30 years since 1900, so 1900 plus 30 represents the year 1930. So again, we're going to solve for t, but we're not going to get the specific answer in year. It's going to be the number of years since 1900. So I hope that clears things up. Which means, knowing that, we are full and ready to go. First and foremost, do we know one of those two variables? Well, if we look at the problem again, or the question rather, it says, in what year was the life expectancy at birth? About 75 years. So that 75 we know is going to be important. Now, is 75 years, does that represent E or does that represent T? Well, that would represent, according to our problem, E. So now we are ready to go. Let's replace E with 75, and everything else that we have not yet touched that does not change simply comes down. Knowing that we don't know what T is, we are ready to go. And that's what we're solving for. So here's the equation again, in which I've plugged in 75. Now we have to solve for T. Now if we look at that, we might think that looks awfully complicated. 75 is equal to 3.66 times the square root of T plus 40.6. Alright, before we get back to this, alright, I want us to take a equation, if I may. What I want us to do is see how this affects our answer and what more we have to do with it. Now just because there's a square root of T around it means nothing. Just because there's a square root around that variable T means nothing. What you just saw, we simply need to do again. Only because there is a square root around that T, we're simply going to have to do a little bit more math than before. So remember, whenever you have a variable involved, really you already know what to do. Okay? Just keep doing the techniques that we already know. So we still subtract 40.6 from both sides, and as I said earlier, that is still 34.4, and that's now going to be equal to 3.66. And before we saw it as just T, well now it is still the square root of T. Alright, so, well, what do we do next? Well, what did we do next before? Oops, sorry for the shakiness there. What did we really do next before? Nothing different. Divide both sides by 3.66. So 34.4 divided by 3.6, again, we are going to round. It's still 9.4, which is now approximately equal to the square root of T. We are not yet done, however. Remember, whenever you're solving for a variable, you want nothing remaining except the variable itself. Nothing remaining. That means everything is gone. Literally everything. Just that lowercase letter remains. Well, that's not the case now. We still have a little square root around the T, which means we need to get rid of it. Think back to last year when we were working with Pythagorean theorem. If you want to get rid of something that is squared, very good. Take the square root of both sides. And it works both ways as well. We want to get rid of something that has already been square rooted, okay? In this case, T. So we want to get rid of that square root. Well, if the opposite of squaring something is to take the square root, it works in both ways as well. The opposite of squaring something is to take the square root. The opposite of the square root is to square it. So we square both sides, because remember, if you do something to one side, you have to do it, well, you know that, okay? So if we find out what is the square root of T squared, the answer is quite simple. It is nothing more than T. And again, I'm going to round 9.4 squared because that's going to give me a large decimal. And we realize that that is 88.3 approximately, which is enough. Which we're just going to say is 88. Okay, right over here. So what was that 88 representing? Well, remember what T was. It was in years. Which means we're representing 88 years since 1900. Alright, so let's think. 88 years since 1900. Is 1900 plus 88, which is 1988. And again, that, ladies and gentlemen, is our answer to the first question, 1988. So, in what year was the life expectancy of a child born in the United States 75 years? The year was 1988. We just solved our first problem. And notice that we did use square roots. Which brings us to your problem, which maybe you see at the bottom of the screen right for you, so you can see it. What this equation has, of course, is a square root sign, which we might not be too used to. We saw that last year with the Pythagorean theorem. We've got to remind ourselves how that works. Now, I'm going to write this equation right now again. Remember, it was 75 is equal to 3.66, but let's remove the square root sign for the time being, and let's just see if we remember how to solve it that way. So here we have 75 is equal to 3.66t plus 40.06. We have to solve for t. And in order to that, remember, start with the number that's quote-unquote furthest away from the variable. We have to subtract 40.6 from both sides. Now, bear with me as I do the math for you. 75 minus 40.6 is 34.4. And that's still going to be equal to 3.66t. Alright, so we're doing well. Now we have to just isolate t. And in front of the 3.66, which is directly in front of the t, of course, means multiplication. So in order to get rid of multiplication, we have to do its opposite, which means we divide both sides by 3.66. We're going to be doing a lot of this type of solving of linear equations this year in algebra. So this is a good preview into what we are going to be doing. Which means we know that this 3.66 and this one cancel out, because 3.66 divided by 3.66 is 1, which leaves us with 1t, which we know we are more than welcome to and encouraged to write as just t. But we do have to do the math of 34.4 divided by 3.66. Well, I don't want to use an equal sign because that is going to give us quite a decimal, so I'm going to approximate it, if I may, to simply 9.4, which, of course, is not our answer. But notice that the way we solved it, we've done in the past. And once we got to t, we were done. We didn't have to do anything more with t. Now I want to... Here it is. All right? Now, feel free to ask your parents, but this question gives regards to Carl Reiner and Mel Brooks and their comedic routine, The 2,000-Year-Old Man. Again, ask your parents. Now, according to this mathematical model, now when I say mathematical model, I mean this mathematical model, okay? That same exact formula. When they say mathematical model, they're just referring to the math techniques that you just used, okay? Whoops. So, according to this mathematical model, in what year will the life expectancy at birth be about 2,000 years? In other words, what year in the future will people live to 2,000 years according to this mathematical model? You're going to use the same equation, and you're going to calculate that. And when you are calculating and you need to approximate, please approximate all your numbers to the nearest tenth. But the final answer should not be a decimal, of course, because you're telling me a specific year in time in the future. So no decimals in your final answer. So the question is, in what year will the life expectancy at birth be at about 2,000 years? Wow. So I want you to do your calculations. I want you to explain your steps. That's very important, to explain what you're doing, not just writing it and showing it, all right? I want you to explain it too. Explain it to me, like I did for you. About 2,000 years. And then at the end, what I want you to do is I want you to comment for just a sentence or two more about why humans living to 2,000 years is a really bad idea. Think about population control. Think about land. Think about even the resources available. Okay? Why is it that humans should not be living that long? Why is this a ridiculous situation? Is basically what I want you to answer. So, you're going to calculate, you're going to tell me what year humans will live to about 2,000, and then tell me why that is completely ridiculous. Alright? And think about it, really. Because it really is. But nevertheless, the math will give us a very, very interesting answer. And there you have it, folks. That is your first screencast. I appreciate you listening. You can submit your answer through Canvas a few different ways. If you want to, you can actually write it out, either by typing it, or you can even write it, handwrite it, that's fine too. As long as I'm seeing your calculations and your explanations, and your explanation as to why that's ridiculous at the end. If you want to, you can also record your voice just saying it. I'd be happy to listen to it that way. Just make sure you are speaking your final answer at the end. Or if you wanted to, you can make your own little video of yourself doing it. You know, kind of like a YouTube video, but of course you don't have to post it to YouTube. But you know what I mean by that. Or if you wanted to, you could, I mean, the possibilities are endless. You can record your voice, you can make a little video, or you can even make a screencast like this of your own, which you are more than welcome to do. You can download a free app called Educreations. I guarantee it is free. It's wonderful. It's how I actually made this one. And you're welcome to do it that way if you want. Submit that. Heck, the possibilities are endless. You can even like make a Vine if you wanted to. Of course, it would be 6 seconds long, but make sure you're getting everything into that 6 seconds. Feel free to be creative, of course. I just want to hear your explanations or see them, or I just want to know that you can explain it to someone else. Okay? That's it, folks. Thanks so much for listening, and enjoy.